Welcome back. This is Mr. B. Hill, and we're going to continue talking about interest. And so before we talked about simple interest, now we're going to talk about compound interest. And so with compound interest, what the bank is going to do is they're going to make you pay interest on the interest that has already accrued. So you have to pay interest on the interest, not just on the principal. So let's just work through an example here where we're going to compound the interest annually. Meaning, like, each year, you're going to take the interest that is accrued, roll that back into the principal, and charge you interest on that new amount. So using the exact same problem, we're purchasing a $16,000 car. So our principal is $16,000. The rate is again going to be 0.065 per year, or 6.5% per year. The time is going to be 5 years. And now we're concerned with the amount that we're actually going to have to pay back, or the amount owed. Okay, so the way this is going to work, we'll have time in years as the independent variable, the amount owed as the dependent variable. So at year 0, the only thing we owe is the principal, $16,000. After the first year, well, if you remember from the exponential growth video, the way we can do this is we're going to be multiplying by either the growth factor or 1 plus the growth rate. So we could do 16,000 times either 1 plus the 0.065 or 1.065. And we've already done this calculation with a simple interest, but that's 16,000 times 1.065, which of course gives us, we're adding on that $1,040 per year from the simple interest problem. So after the first year, we're going to have to pay back $17,040. Year 2, we're going to be paying interest not on just the $16,000, but on the $17,040, or looking at it this way as this amount, 16,000 times 1.065. So we need to take this new amount and multiply it by another 1.065. Or after 2 years, we're going to be paying back 16,000 times 1.065 times another 1.065, or we just make that 1.065 squared. 16,000 times 1.065 squared means that now we're going to have to pay back $18,147.60. Year 3. Well, we now take this new amount, or if you want it, we can write it this way, and multiply by another factor of 1.065. Or that just becomes 1.065 cubed. So 16,000 times 1.065 to the power of 3 means we're paying back this amount, $19,327.19 plus another 4/10 of 1 cent, but wait, how do we get 4/10 of a cent? Well, keep in mind, there's no actual money involved in here. This is just a calculation that the bank's going to do before they even give you the loan. So they're going to try to calculate the interest on this 4/10 of a cent because, well, keep in mind they're making so many of these loans that these fractions of cents will actually add up over all of the loans over all of the years. 4th year. Hopefully you can see the pattern here. We're just going to multiply by another factor of 1.065. So the exponent becomes 4. And so it goes 16,000 times 1.065 to the power of 4. And we get this amount, $20,583.46161. And then finally, for 5 years, 16,000 times 1.065 to the 5th power. Right? One more factor of 1.065. Oops, I meant that to the power of 5. And there we go. So we're going to have to pay back $21,921 and about 39 cents. We'll round it off there because that is going to be the actual amount that we have to pay back. So they're going to take this amount now, divide it up amongst 60 months over the 5 years, and that'll give you your monthly payment. But you still are going to have to pay back this total amount. Okay. So let's compare this to our simple interest. So the amount actually paid for the car under simple interest, we had to pay back $21,200, meaning that the bank actually makes that interest of $5,200. By switching up to compound interest, all of a sudden, we end up having to pay back $21,921.39. So what happens now is the bank makes about, well, let's see here, from $21,200 to $920, that's about $720 more, just by changing the word simple to compound in the contract of the loan. Kind of nice for them, right? Well, that's not the end of the story. Suppose the bank wanted to compound the interest monthly. Yes, they can do that. So what's going to happen here is every month they're going to roll the interest accrued back into the principal, and you have to pay interest on that interest. So what they're going to do is we're going to divide the annual interest rate, R, by 12 to get the monthly interest rate. So now the monthly interest rate is going to equal 0.065 divided by 12. Doesn't really matter what that actual amount is, because we can just type this expression into the calculator. But just to be sure, 0.065 divided by 12 is approximately 0.00542, or about 0.542%. So 1/2 of 1%. Okay. Doesn't really matter, but it's a pretty small interest rate. But the way this is going to work is we actually have to pay interest on the interest accrued each month. So now the term of the loan, instead of looking at it in terms of years, 5 years, we're going to multiply that by 12 months per year. And so the actual term of the loan is the same amount of time, but we're looking at it as 60 months, or 60 compounding periods, because that's how many times we're going to have to multiply by this same factor over and over and over again. So let's look at that in a table here. So we'll let month be our independent variable, and the amount owed will be the dependent variable. Month 0, no interest is accrued, so we only have to pay back the principal, $16,000. After 1 month, we have $16,000 that we owe back, but we have to multiply that by 1 plus the monthly interest rate, 0.065 divided by 12. Right? The 1 tells us that we have to pay back the principal plus this monthly interest rate times the principal. Right? You can see that just by distributing in that 16,000. So what that gives us is 16,000 times 1 plus 0.065 divided by 12. 16,086.666. Repeating. After the second month. Now I have to pay interest on this new amount, which we can also write this way, meaning we're just going to multiply it by another factor of 1 plus 0.065 over 12. Or we just write that in this way, squared. So we multiply this by another 1.065, excuse me. Let's just times 1 plus 0.065 divided by 12 to the power of 2. So that's this amount. And these amounts really aren't that important because what really matters is the calculation at the very end. So after the third month, we're going to take this new amount and multiply it by another factor of 1 plus 0.065 divided by 12. Or this is going to be 16,000 times 1 plus 0.065 over 12 to the power 3. And you see how, hopefully you see the pattern here, because this is just going to continue on and keep doing the same thing. So we don't really even need this intermediate calculations here, because we're going to have to do this for all 60 months within those 5 years, which are the term of the loan. So for 60 months, we've taken 16,000 and we've done the same thing 60 times, meaning that we have 1 plus 0.065 divided by 12 to the power of 60, which is, well, let's see here. And so this is 22,125.08 cents. Rounded off there. So that's the amount that we're going to have to pay back. But that leads us to the actual formula for compound interest. Well, the amount that we owe back is equal to the principal times 1 plus the annual interest rate divided by the number of compounding periods. And here we took the annual interest rate divided by 12 to get the monthly rate. But then the exponent is going to be the number of compounding periods in the term of the loan. So we take the number of compounding periods, which I'm going to call n, and multiply it by the number of years, or number of compounding periods per year times the number of years. A is the amount owed. P is the principal again. R is the APR, the annual percentage rate. N is the number of compounding periods per year. And T is still the term of the loan in years. So that's exactly what we have over here. Principal times 1 plus the annual rate divided by 12 compounding periods per year. This 60 is 12 times 5, 12 months per year times 5 years. So let's compare these amounts again. We had a $16,000 loan, paid back over 5 years at 6.5% APR. The amount we actually have to pay to the bank well, for the simple interest, again, that was $21,200, which meant that the bank made $5,200. Compounding annually, we ended up having to pay $21,921.39, which meant that the bank ended up making about $720 more just by changing from simple to compound interest. Compounding monthly, that ended up being, I believe it was 22,100. Let's go back. What was that again? Yeah, $22,125.08. Okay. So now if we subtract off the previous amount, let's see here, 20, that looks like, okay, from 120 to 1,000, that's not going to be all that much really. $22,125, subtract off $21,921. Okay, so we make about $204 more. Just by switching from compounding annually to compounding monthly. Kind of nice for them. Let's try one more here. So if we're compounding, how about daily? Yeah, they can do that. So the formula, A is equal to the principal times 1 plus the rate divided by the number of compounding periods per year times the number of compounding periods per year times the number of years. So A is equal to 16,000, that's our principal, times 1 plus 0.065 was the annual rate. Now we're dividing it by 365 days per year. But now our exponent is going to be how many days there are in those 5 years. So 365 days per year times 5 years. And we can just do that really quick in our calculator. Times 1 plus 0.065 divided by 365. All of that is going to be raised to the power of 365 times 5. And all of a sudden, compounding daily, we have to pay back $22,143.85. That amount more than the $22,125. So we subtract off $22,125. We see that we get about 19 bucks more. Just by changing from monthly to daily. Kind of nice that you can just change a word and all of a sudden make significantly more money. Now, there is even more to it than this if we really wanted to. You can compound continuously. Now, deriving this one is going to involve a little bit of calculus, but basically here, The idea is that we're not compounding every day, we're not even compounding every hour, we're not compounding every second, we're compounding every single moment continuously. Well, the formula for that one is given by the amount owed is equal to the principal times e to the power of r times t. P is still the principal, r is still the annual rate, t is still the term of the loan in years, e is Euler's number. Very special number. It's a lot like pi. It's an irrational number, even transcendental. It's about 2.7 something, whatever, but it doesn't really matter. So even if we're compounding continuously on this, the amount we're going to have to owe back is going to be 16,000 times e to the power of 0.065 times 5. Let's see what that is. Times, e is the second function on that one, to the power of 0.065 times 5 years, $22,144.49. Well, not much more, 50 cents or so. So not much. And we're not going to do much with compounding continuously. You'll look at that more a little bit in Algebra 2. But anyways, if you want to look at some problems from the Personal Finance Day homework, you might look over that. We're going to be working through a bunch of those type of problems in class. And so, thanks for watching.